Hello everyone, my name is Haoyi, and I'm going to be talking about cross-platform development in Scala.js. Scala.js is a Scala to JavaScript compiler which lets you take your Scala source code, compile it to JavaScript, and then run it in the web browser like any other JavaScript. So it lets you do cool things like share your source code between client and server, or get type checking in your web apps, which are traditionally made but with something like JavaScript or CoffeeScript, which are kind of soft, squishy languages that keep making mistakes. And the code you end up with ends up being about a few times slower than raw JavaScript, quite a lot slower than Scala, but nevertheless it's still fast enough for many purposes. It's a lot faster than Python for what that is worth. So what's wrong with JavaScript, and why would you want to use Scala.js? So at work, I work on our CoffeeScript code base, and I find that many of the things that people bump into when they work in the code base are the same no matter how long you've been working in CoffeeScript, how much industry experience you have, or how smart you are. Things like, why is this variable undefined? Or, I want to refactor this, but I'm scared, so I don't. So it's that kind of very menial, low-level problems. No one is writing big algorithms to do cool things with a web page. People are just struggling against a stupid code base, trying to make it not crash when they make their changes. And in reality, no one actually knows what's going on. Some people tell other people what to do, but they don't know what's going on either. So just to show you how Scala.js works, here's a short little demo with Scala.js. So I'm going to set up SBT to do live reloading. And over here is a small Scala.js application. It defines a point class. It gets a canvas rendering context from the browser, and sets an interval which starts this little loop. Each time the interval runs, it runs this loop 10 times, and this loop goes around the canvas putting points. And if you recognize it, this algorithm basically gives you this Sierpinski triangle drawer. And the actual algorithm is kind of irrelevant here. What's interesting is that I can mix things like Scala sequences and Scala points with things like canvas rendering contexts, which are defined in JavaScript. Is this fellow, canvas rendering context, and aren't even defined in Scala at all. What else is interesting is I've hooked it up with the web browser, such that when I change stuff in the code, I should get SBT log spam in the browser, and it should reload on its own. So the first time you change things, it's kind of slow. After a while, it speeds up as the compiler warms up. And so this is kind of interesting, but let's try making it more interesting. So I'm going to try turning this into a video game in the next 5 minutes. So to make it a video game, first, I don't want to run this 10 times. I want to clear the canvas every time. I don't need corners. I don't need count. I'm going to rename P to player, and don't need this anymore. And I'm going to make the player a 10 by 10 rectangle. So this is blowing up, doesn't compile because of this fellow hasn't been changed yet. Let's make the player white. So as you can see, when you screw up in Scala.js, you get a nice compile error, not just in IDE, but also in the browser in SBT console. So has this guy worked yet? OK, so now it works. So I have a player in the top left, which is white. So let's move him to the middle. And let's look at adding some input. So the way you work with input in Scala.js is the same way you work with input in JavaScript. You basically use the DOM APIs. For example, one thing you can do is say, I want to set the on key down method of the DOM. And you can see that I get nice doc strings in the browser. It's pretty neat. Event handler, I grabbed them from MDN. So this guy is a dom.keyboard event, and I can do things with it. So should do that. OK. So what I can do with this is, for example, I could print out the event's key code. Let's say that's the integer which represents a keyboard event. And I get numbers. So in order to make the player move around, I'm just going to keep track of what keys I have pressed. And I'm going to, which is going to be a set of integers. I'm going to just add the keys whenever they get pressed down. And I'm going to remove them whenever they get pressed up. So that is on key up. And so here, if I print out the set of keys, you can see that I have a mutable set that, depending what I have inside, will change. And I can change this to, instead of printing it out, I'm going to set if the keys for the key code is a constant, basically a bunch of constants that I made that holds a bunch of keys. So I don't need to remember what number is which. Play plus equals 0.010. Should we probably be negative 10? Let's say 2 for now. Down will be positive 2. And I'm going to make left, and I'm going to make right. So this is going to be negative 2, 0. This is going to be positive 2, 0. And if everything worked, now I can control the player moving around the screen. So that's quite neat. It's been, let's make it a bit faster so it doesn't take so long. So it's been about 3 minutes since I started. Now I have a kind of working video game. So in order for a video game to be interesting, you have to be able to die. So let's give myself some enemies. So enemies are going to be a sequence of points. Let's fill it so I don't need to make them manually. I want 20 of them. And each one's going to be a random number, random point from 0 to 255, 20255. I think I did that right. Let's move this down so it fits within the screen. And for each enemy, in enemies, I basically do the same thing, except I'm going to make the enemies red. So let's take this guy, move him down here, and make him red. And now I have, OK, that's wrong because I'm printing on top of my player. So I should be doing and printing the enemies x and y. So I have a bunch of enemies. Not very interesting. I can't die yet. But if I add a little if statement that says if I'm too close to enemy, so let's say player.x minus enemy.x less than 10, and player.y minus enemy.y less than 10. So I probably need a alive flag somewhere, so I'm going to set that to start off true. And this probably needs to have a math.abs, because otherwise it'll only detect one direction, not the other. So math.abs. So I shall move this down so it fits. Alive equals to false. And if I'm alive, I do this stuff. I don't move. If I'm dead, I don't move. And my context.fill style, which is the JavaScript API I'm just using, is going to be, let's say, gray to represent dead. Let's get rid of the space. So if you let that spin up a bit, you can see it's getting faster to recompile. Now if I hit something, I stop moving, and I turn gray. The last thing to do in this game is to make the enemies move, and that can be done pretty easily just by saying enemies equals enemies.map. E goes to a point, e.x, e.y plus 2. And now you'll see all the enemies are moving, and they all run off screen and disappear. So I probably need to make it e.y plus 2 modulo like the size of the screen, and then they won't disappear. So now they're moving. If they hit me, I die. That's pretty neat. I have a kind of working video game. If I want to make it harder, I can just make the enemies move faster. So let's make them move at double my speed. And here we go. And it's pretty hard. OK, so what's interesting here? I've made a working video game in the last 5 minutes. So let's take a look at this game. Currently, it compiles down to JavaScript. And if you look at this thing, if you will let me see, because it's kind of small, let's make it bigger. The JavaScript bundle it compiles to is 764 kilobytes. So this is without any fancy optimizations. It does some, actually it's with some fancy optimizations, but without all the fancy optimizations. So to ask it to do more fancy optimizations, I swap out fast optimized JS with full optimized JS. This normally takes another maybe 10 seconds per run, which is why I don't do it all the time, because it takes a while. But it's not so long that I can't do it once before you actually put the code out on the web, for example. So has it already optimized it? I think it has. OK, so that's done. So I'll change it to the optimized page. And you see it looks exactly the same, except now the final thing is 126 kilobytes of JavaScript without gzip. So that's pretty cool. Let's spend a moment to reflect on what we have done. So if I open up the code that I just compiled, which lives in here, The fast optimized code, I hope it doesn't crash my editor, looks like that. So it's kind of verbose and long. What the fast optimization does isn't compression as much as dead code elimination, and to some extent, inlining. So it makes the performance better. It makes it go from 20 megabytes to less than 1 megabyte. But still it's kind of readable. So if you look at it and kind of figure out what's going on. So if I look at, for example, collection, mutable, I misspelled mutable, seek. Where is seek? Maybe we don't have seek. Oh, because I didn't use mutable seek. But if I use mutable, so it got eliminated. But I use mutable set? No. OK, I don't know what happened to it. But anyway, so this is generally what the code looks like. If you look for my code, which lives in Scala.js example, Scala.js example, it's basically here. So the code is kind of verbose, but it more or less flows the same way because Scala is actually not that big a difference from JavaScript in that you call methods the same way, you pass arguments the same way, get return types the same way, except it's really verbose. On the other hand, if you look at the fully optimized version, it kind of looks like this. So this is what the Google Closure compiler does to your code. It makes it a lot smaller. You can't read it, probably. But because Google Closure compiler is correct, because lots of smart people work on it, it doesn't break the code, and the code works the same way, like here. So that's enough for this demo. And let's go look at something else. So what some guys you may be thinking may be, what can I do and what can't I do in Scala.js? I've showed you can use collections. I've showed you can use a DOM. But what else is available or not available? So you can use almost all the Scala standard library. You can use some small subset of the Java standard library, but not most of it. You're not going to be able to use org.ohmygod.corba, for example. You can use macros. You cannot use reflection. The reason you cannot use reflection is because if you use reflection, we can't do dead code elimination anymore. And maybe we could work around it with fancy annotations like ProGuard does, but we didn't. So currently, you just no reflection. And you can use all of the pure Scala ecosystem. So if your program is in Scala and does not depend on Java specifically, or Java virtual machine, you can use it. Someone's ported Scala-Z, someone's ported Shapeless, in case there are any crazy super functional programming people here. And you can't use things like Scala test, unfortunately, because it uses a lot of Java APIs and uses a lot of reflection, which is why I wrote my own microtest library, which is kind of similar, but without all the reflection and Java stuff. Other things. You cannot use JVM operating system networking. You can use browser networking. So you can use a new hotness like WebSockets and AJAX calls. You can't use OpenGL. You can use WebGL. You can't use Java libraries. You can use JavaScript libraries, including quite big ones. I'm going to show you a demo using Chipmunk.js later, which is a several thousand line of code JavaScript physics engine. And you can use all your old Scala like tooling. So things like SVT, incremental compilation works great. IntelliJ doesn't even know it's a Scala.js project. It just works. And you can use the Chrome console for debugging. So you can see I have things here. And if I do something bad, like let's say I go here and make it blow up, throw new exception, boom. And let's move this down a bit just to see what's happening. So silly me, let's make it do the fast optimization so it doesn't take so long. So if we spin that up, spin, hurry up, SBT. If you spin that up, you'll see that when it blows up, you get a nice stack trace in the browser, just like you would in the JVM, except instead of being in the console, you get it in the Chrome console. So if we run this, whoops, I'm still running the optimized version, sorry, dev. So you get an exception, and you get a bunch of weird-looking methods with Scala stack traces. So that's pretty interesting because we have source maps. So it's kind of like CoffeeScript. We just so Sebastian set that up, and it works great. And for example, you can see this blew up on line 62. I don't actually know if that's accurate. Yep, that's accurate. OK, cool. So so now for a bit of show and tell. So I've showed you a small thing you can make in 5 minutes. So here's a few bigger things that took a bit longer. So first is this little to-do MVC application, which I made a while ago just to show off Scala.js. You guys may have seen this kind of application before because people use it to show off, like, look how cool my new JavaScript framework is. I can do this in less code than the other people can. So it basically works the same way as any of the other examples. If you Google to-do MVC application, there'll be a whole bunch of examples. And there's even some to-do MVC application company which kind of owns the copyright for this thing. But what's interesting is if you look at the source code for this guy, it is 150 lines of code. And that involves all of the HTML, all of the, which is kind of lives down here, all of the event handling, all the updating, and all of the state that lives on in the JavaScript. So here's my list of tasks that gets updated when I click things. If you notice this little framework thing, which seems a bit suspicious, but it's actually like 3 functions, function, okay, 4 functions. And basically, this is about a third the size of most other JavaScript implementations of the same application. So I think React.js is about 400 something lines of code. Backbone.js is maybe 800. There's an Angular implementation, which is about 300. I think that's the closest to what we have here. That's including both the HTML of Angular pseudo HTML and the JavaScript, excluding CSS, because we all have the same CSS. So that's pretty neat, and it's kind of a different thing from what I was showing you earlier, where it was just a canvas drawing stuff on. Here, you actually access a DOM a lot. You're rendering big blobs of HTML. Here, using my Scala tags HTML library, which takes a bit of getting used to, but is very concise to use. And generally kind of just shows off that you can make websites with this, kind of. Like, it works. I haven't made a very big website with it, but in theory, it should work fine. Next thing to show you is Roll. So Roll is a cute little application that was what first got me into ScalaJS. And what it basically is, it is a 2D platformer that is written entirely in ScalaJS. So if you're SF Scala a long time ago, I showed this off before when it was still black and white and didn't really have many levels. And now I have a whole bunch of levels, including pretty fun ones like this. And the goal is to roll your ball into the center of the screen. And the gameplay logic is all written in Scala. It runs in the browser. If you look at how big it is, how big is it? Reload. This is about 280 lines, kilobytes of JavaScript, gzip to 80, which is reasonably small. It's about the same size as jQuery. So that includes the whole Scala standard library that I'm using, as well as maybe 2,000 lines of Scala code. So it's actually pretty reasonable. And I have a bunch of levels. Some of them are pretty hard, like this one, because if you touch any of the red things, you die. But in general, this kind of just shows off, like, you can make pretty complex things with Scala.js. Maybe I haven't tried making big websites yet, but big 2D applications work great. So the last thing to show off is the Fiddle, which is a little website I made, which, if my internet doesn't die on me, will let me run Scala.js snippets in the browser. So here's a little one, which makes a little oscilloscope. It's kind of a cute example because it's pretty small sequence of functions that you can call, like, literally math functions, and it just plots them out over and over. And you can change things, and it re-renders. You can change things to, like, purple. I want it purple. And I want this to be twice as fast because I'm OCD. So you look at it, it goes twice as fast. Nope, I screwed up my math. That's twice as fast. OK, so, and it lets you draw things and otherwise do things in the browser without having to open up your editor. What's interesting is this whole website is written in Scala, and so is the back end, and so is the front end. And all the Ajax-y stuff is done in Scala. And in total, it is 1,000 lines of code for both front end, back end, all the Ajax, all the compiler interfaces. And you can do interesting things with this 1,000 lines of code. Like, you can do anything you want. For example, here's a to-do MVC application. I basically copy and pasted the whole source in here, and it works, which is quite neat. And here is a ray tracer, which is my favorite example because it's very pretty, and it's written in Scala. Here's a scene definition. And it just kind of shows, like, yeah, this actually does work. It's not just 1 + 1 anymore. And it's not just like, oh, look, I've turned the DOM red. Wow. Like, you actually can do pretty neat things, and it's not super fast. But, like, ray tracing is never going to be fast, so that's OK. So that's it for the show and tell. I hope you guys found it interesting. Let's move on to something else. So I promised, some things about why you want to use Scala.js is that so you may want to use Scala.js instead of JavaScript because Scala's nice. You may want to use it instead of something like Kotlin or Dart, because we have a lot bigger ecosystem than they do, most of it for free. Like the Dart people have a whole team working on their Dart Eclipse plugin, and we have 2 IDEs that we got completely for free because they don't even know they're working with Scala.js. You may want to use it instead of Swing apps because emailing people jars and getting them to run jars and getting a class path right is actually pretty difficult, and I've tried it before. And lastly, because front-end development in JavaScript is actually pretty fun, and you can make a lot of progress. Sorry, front-end development in Scala is pretty fun. You can make a lot of progress very quickly because of all the tooling that you get. So that's for the short examples. Let's go into a slightly longer example. So this is going to be a server-client application. And I'm going to cheat and use a reset hard head. I'm going to use a pre-populated example because it's a lot of code to write out. You can see just setting up a server and client has a few dependencies. I need to get spray, I need to get akka, I need to get blah, a bunch of things. So rather than typing it all out in front of you, here it is. So what we have here is a project with 3 main modules. When you reload, you'll see it has client, it has server, and it has shared. So client is basically a Scala.js application, which renders an input box, renders some text, not some text, some HTML, and on click, it updates the text it has rendered. Server is basically a spray can application, which contains a little HTML fragment up here, which is a skeleton of the page, as well as a small spray route, which says, for the root, just give that skeleton, otherwise give the resource, and for any API calls, wire it to the right place. So this results in a small application that looks like this. In total, it's about 100 lines of code, 60 here, 50 there. And basically, you can look at your file system. It's not really very useful. Maybe if you really want to look at all the things that your compiler spits out, you can. But the point is just to show a mini example of how you can use Scala.js with client and server. So what's interesting about this application is that you can do things like share code between client and server. So for example, the simplest code you can share is probably an interface. And over here, you'll notice that if you look in the client, where is the AJAX call? Well, the AJAX call is obviously here, but where are all the strings that are normally associated with AJAX calls? Well, I don't have any strings. It is a strongly typed method to an interface. And this guy will get pickled and sent. He's a string. He get pickled and sent automatically. This guy, who happens to be a sequence of strings, will get pickled on the server, sent back to me and unpickled automatically. And this fellow has a pretty readable signature. Basically, you can call any AJAX function that returns a R, and it'll give you a future of R, which is kind of like what AJAX is, right? It's an asynchronous request which may fail. And there is some macro magic which I've done in order to do things like capture these guys and pickle them properly, because that doesn't happen by default because it's not really part of the Scala type system. But anyway, the point of this is that I have an AJAX call here. If I want to find where it is on the server, I can just click this thing, and here I am. So I don't think, in my experience working on the web, this has never been the case. It usually involves lots of grepping and some swearing. And here, your editor can tell me, oh, here, that's what AJAX call is, and here's who's using it, and here's where it's defined. And if you want to do things, for example, let's say I want to go to my server, which is this guy, and I want to make it return not just the file name, but also the file name with its path. So map f goes to f, I think it's prefix plus f. This is probably wrong in some way, but it'll serve to illustrate. You'll see that it's compiling, and then it yells at me saying, nope, you did not change the signature. And I did not change the signature up here either. And now it's going to tell me I didn't change the signature down there because I didn't. Name, path. Let's make the name bold. Name plus, let's do that. Path. OK, and now you'll see that after everything is finally compiled, everything works again, which is I don't know how many of you do web stuff, but this is very rarely the case when you're working with CoffeeScript. Because when you're working with CoffeeScript, you have nothing to check these things for you, and you end up with a lot of grepping, maybe a few crashes in production that will then get the sales team paged, which will then page you, which will then result in an emergency push to prod to fix some typo or some call site you missed. But with Scala.js, it's tied together very nicely, such that if you make any sort of mistake in the client-server interaction, the compiler will tell you, whoops, you forgot something. And like, even before you compile it, if I make a typo, for example, I fat finger it, it tells me right in the editor, nope, there's no such thing. So one more thing that you can do is that if you want to instead of returning a tuple, maybe you're one of those guys who hates tuples and you want to return a case class, you can do so. So I'm defining a case class which is called file data. Let's give it a name and a path. And I return a file data. So you guys probably already can guess, but this guy's going to keep yelling at me until I fix all the call sites. So I probably don't even need this thing anymore because of type inference. I didn't need him in the first place. And so I need to fix him, and I need to go to the client, who is no longer getting tuples and is returning a file data. And everyone knows it's returning a file data. Even my editor knows it's returning a file data now. And if I get it to reload, you'll see that, again, it works, which is pretty nice. And one other interesting thing is if you look at the network console to see what is actually happening, let's say I do a bunch of typing here. And this is clearly wrong, but ignore it. You'll see that I'm actually sending down nicely structured JSON. Well, for one, I'm sending up nicely structured JSON, if you can see. And I'm receiving back down nicely structured JSON, which is all generated automatically by the macro. Well, not by the macro, by the implicits, which are in scope. If you want to, you can change it, but by default, case classes resolve to JavaScript objects. If you go back to our previous example, which I'm probably not going to because it'll take a while, tuples will just become like a list of 2 things, and a string is just a string. So all this is handled automatically for you. And if you want to, you can customize it. By default, you probably shouldn't need to. And if you realize what we've done here, we have defined a shared data type, which we can share client and server. And not only can we share this client and server, we can easily just like chuck the data type across the client-server boundary and have the other guy pick it up correctly. And it's even kind of type safe, such that if I do something wrong, let's say I make this guy return java.io.file. Let's try to make this guy I need to make this guy return a java.io.file. Well, let's make it this guy. Let's just make him blow up because it shouldn't compile if I did this correctly. You'll see that, oh, the pickler does not know how to write Java.io files. So this is actually quite nice because it means that even if you try to screw up, you probably won't, unless you intentionally write a malicious pickler that will cause it to explode. By default, the only things you can pickle are things in a standard library, which I've defined for you. There's a big list of them. So if you look at this guy, well, there's a lot of generated files. And implicits, there's a list of all the standard library things you can pickle, and case classes, which are pickled by a macro. And that's it. So you don't need to worry about things like, oh, someone's going to inject something which will cause a constructor to run, which will blow up my program and take control. You really only pickle and unpickle things that you know statically what they will pickle to or what they'll unpickle from. And just for convenience, I provided all these things, but there's no magic in this pickling. It's actually pretty straightforward, and the library which does the pickling is less than 1,000 lines of code. So this is pretty nice. So if we go back to the slides a second, what have we seen here? So one thing that's nice is I can use the strengths of each platform such that if you look here on the server, I'm using Spray. That's pretty cool. On the client, I'm using the DOM. That's also pretty cool. If I try to use Spray on the server, it does not work. Is it IO Spray? No, it's just Spray. Just because the module does not depend on Spray, so it knows not to let you use Spray. And similarly, if I try to use a DOM on the client, again, you just can't use it because it's not available. So that's pretty nice in that you're able to use the strengths of each thing. Yeah?
Just
5 minutes more, OK. You're able to use the strength of each thing, but you won't accidentally use the other thing, because not only will the compiler yell at you, even your editor will yell at you saying that, nope, this is not allowed. And sharing code and libraries and data structures between the client and server is pretty nice. So you guys already saw that I have a little data structure here that is shared. What you guys saw but did not realize is I have multiple libraries which are shared. This Scala tags library is a HTML generation library, which I made, which works on both client and server. Like, there's no reason why HTML generation library shouldn't. It's just splicing strings after all, and so it does. uPickle, which is a pickling and unpickling library I made, also works on both client and server, and is also shared. And if you look at my SBT project, which is here, you'll see that I have dependencies on both the JavaScript version, represented by 3 percentages, and the Scala version, represented by 2 percentages. I think this guy gets pulled in automatically, so I probably don't need him, but never mind. And similarly for the Scala tags and Scala tags, well, that's not true, because here I'm using the 3 percentage one anyway. And that's OK. Well, it doesn't blow up, because all it means is you have some extra JavaScript files in the jar artifact. Like, it doesn't actually do any harm. So back to the slides. Static typing keeps things straight and keeps you sane. As I showed you earlier, we actually have 3 modules. And you can use different subsets of your APIs in each module. And because of static typing, you're quite sure you won't screw it up. So cool demos. I've already showed you sharing libraries between client and server. What else can you do? You can also share, you can also automatically rename AJAX calls. So in order to do that, first I'm going to fix this guy to not return Java IO file. And I'm going to fix this guy not to blow up. And then I'm going to come here. Well, come on, reload. I'm going to come here. I'm going to say I want to rename this guy, the base member, to list new name lols. And then once it's done compiling, oh no, the type checker blew up just now. That's not good. Come on. Once it's done compiling, you'll see that it should, well, even before it's done compiling, you'll see that over here it's renamed this guy correctly. Over here it's renamed this guy correctly. And when it's done compiling, you'll see that the actual route has been changed, such that now instead of hitting the /list endpoint, I'm hitting /list new name lols endpoint. And that's actually, again, a thing that's pretty nice, because my experience working with JavaScript and CoffeeScript is that when you do these things, there's like a tinge of fear that goes through your body, and you don't know whether you'll break things, you don't know who's going to yell at you. But with Scala.js, because the editor can help you do all these things and compiler can check it, there is no fear. I just renamed it, and it's a new AJAX endpoint, and maybe new name lol makes sense in your company's business context. And so you get find usages. That's pretty neat. Like you probably already know, because IntelliJ doesn't even know it's a Scala.js project. I can ask for it, ask it where it's being used. You get lots of safety. I've already showed you. You can't misuse things. And you get toolability. So I already showed you toolability around AJAX. Let's spend a moment to talk about toolability on the client. So you guys already saw me do stuff on the client, but the fact they can have autocomplete with documentation, with like jump to definition in case you want to see what this thing is. So these are all question mark, because they're just stubs for the JavaScript interoperability. So they actually call to JavaScript attributes. And I can say things like, oh, I want to get all the children. Which children? Oh, this children, that children. Maybe I want this children. For child in children, child, what do I want to do with the child? Maybe I want to get his client height. Maybe I want to do something else. Maybe I want to set his outer HTML. What does outer HTML mean? Oh, outer HTML means this, which is probably screwed up content. It's HTML, but if you look at out here, you can see outer HTML does a particular thing. If I want to see what inner HTML does in comparison, I can. And all this is done without leaving my editor, because you have all this documentation on the Mozilla Developer Network. Because all of it's done in these plain text HTML, inconsistent HTML formats, there's no way for you to parse it and actually get useful in-editor support with it. But because I have done the tedious work of going to the Mozilla website and copy and pasting everything with proper attribution, of course, now that even when we are in our editor, we know that, oh, this guy returns a string. And because of all the stubs, I can see that, oh, if for some reason I need access key, also returns a string. So to wrap up, cross-platform development in ScalaJS is actually pretty fun. Like, you can do a lot of things. And as someone who works with CoffeeScript and Python at work, I think that this, in theory, solves many of the problems that I face day to day, like what the hell's going on? Why can't I do this? Why is it breaking? And if you want to come hang out, we have a website, we have a Google group where people are doing interesting things. The examples I showed you are here on the GitHub, different branches. And I'm just going to put up a picture of the ray tracer because it's pretty while I take questions.